Okay, hello everyone. Welcome back to the Topos Institute Colloquium. Today we're very happy to have our own Brendan Fong talking to us about abstractions for real people. So please, Brendan, whenever you're ready.
Great. Well, thanks, David, for the introduction and the kind invitation and persistent invitation. I'm glad to finally be speaking in this colloquium after 5 years. And I'm also glad to have the privilege of an in-person audience, which is rare for this colloquium, but there are people here in the room with me. So today, in reflecting about what I wanted to do with this talk and this opportunity to address this community, I thought instead of presenting some sort of polished research results and polished slides, I wanted to open up Topos a bit and share a conversation that we have internally about, the practice of our work. So moving from sort of just the mathematics as a technical enterprise to a sort of socio-technical enterprise. And so the spirit of this talk really is sort of an invitation into work in progress and an invitation to reflection and inquiry with us. And as a result, the results, the things I'll be talking about are sort of broad ranging and a little messy, but I hope you'll sort of enjoy that spirit and enjoy the conversation, the discussion at the end, and also, in the days and weeks and months to come. In terms of a specific sort of orientation around questions for this talk, then please feel free to especially ask clarification questions anytime, and also raise other questions in the talk as it goes if you feel like it. But I think it'll be most meaningful to have a bit of proper discussion time at the end. So if we're having too much discussion within the talk itself, I'll try and sort of shepherd things so that we restrict it internally in the talk and then talk more at the end. Great. So the main sort of thesis of this talk is quite simple. I'm going to talk about, again, this practice of mathematics or this practice of abstraction, and put forth for discussion that it supports sort of real people, whatever that means, when it has these qualities of being accessible, responsive, and pluralist. And I'll give some precise definitions about what I think I mean by these words as the talk unfolds. The second thing I want to put forth is that this is a complex sort of a complex challenge, a complex opportunity. A practice of abstraction is a socially sort of wide, far-reaching thing. But I do think that the category theorists, that is our community, that does have something unique to contribute. And so I want to speak about that too. So all very abstract so far. I thought I'd begin by just telling some stories. The first one is about death. Hey, yep. Oh, okay, sorry, with this thing because it's mirroring my screen. There we go. No. The International Classification of Disease, ICD, is a worldwide standardized system for classifying diseases that's used in collecting mortality statistics, among other things. Without a centralized standardized system, the data collected by various offices won't aggregate. But the ICD has highly variable granularity. It has separate categories for accidents involving falls from playground equipment, falling from a chair, falling from a wheelchair, falling from a bed, falling from a commode. But it only has 2 categories for falls in the natural world, falling from a cliff and an other fall category that lumps together all the other falls, including, for example, falls from embankments, haystacks, and trees. The ICD is obviously much more interested in recording the kinds of accidents that might befall people in an urban industrial environment than a rural environment. And C.T. Nguyen goes on to say that this classification system it does benefit certain people more than others as it aggregates statistics about mortality and is used by the World Health Organization in these matters of global health. My second story comes from Cathy O'Neill's Weapons of Math Disruption. So the context here is DC, Washington, DC is trying to improve its public schools. And so the new chancellor of DC public schools developed a teacher assessment tool called Impact. And at the end of the 2009-2010 school year, the district fired all teachers whose scores put them in the bottom 2%. Sarah Vysotsky a fifth grade teacher didn't seem to have any reason to worry. She, by all accounts, is a very competent teacher. One evaluation praised her attentiveness to the children. Another called her one of the best teachers I've ever come into contact with. Yet, at the end of the 2010-11 school year, Vysotsky received a miserable score on her impact evaluation. Her problem was a new scoring system known as value-added modeling, which purported to measure her effectiveness in teaching math and language skills. That score, generated by an algorithm, represented half of her overall evaluation, and it outweighed the positive reviews from school administrators and the community. This left the district with no choice but to fire her. And so the story from here goes that, she looked into, and a team of people looked into, the rationale for this decision. This method of value-added modeling takes basically a key component of evaluation as the difference between the students' test scores as they were exiting their previous class, and then at the end of the class that Vysotsky taught, the school year. And the rationale is quite simple. A good teacher improves test scores. So if you look at the difference, that's a great way of figuring out who the sort of poor performing teachers or the uncommitted teachers are, and getting rid of them to improve the school system and making sure everyone gets a good education. The challenge is that as they looked into it, her students were coming from a collection of elementary schools, and the scores that they had exiting the main school or the schools were sort of irregular. They had, for example, a reading proficiency average grade that was 5 times the district average. And they're ranked as the highly advanced reading skills, but then when she gets them into a class at the beginning, she realizes that many of them still struggle to read simple sentences at 5th grade. And so looking into things further, it comes out that it seems like there are records of people changing the test results for the school for these students as they exit the class, and there's sort of an obvious motivation to do this, as the previous year's teachers both their jobs on the line with poor test scores, and also there are bonuses up to sort of $8,000 attached to good test scores, right? So Vysotsky takes this evidence to the school board, and they agree that it's very plausible, but nonetheless say that the decision has been made, and it's the right decision, and she remains fired. And then a couple of days later, just on the back of strong, advocates within the teaching system, she just finds a job in another school district that is much more affluent, and doesn't have these sort of pressures to, reform the school district. So the end result is not so much that that this teacher is out of a job, but that a good teacher transfers from a poorer school district into a more affluent school district, and that the students themselves suffer. Okay. Finally, coming from Stuart Russell's Human Compatible. So Russell is a professor here in Berkeley. He's well known, for example, with Peter Norvig for writing what has become the standard textbook on AI. So he's a leading expert in the field. And he's talking about just the challenges he sees ahead with AI and potential for catastrophic risk. So he says, to get just an inkling of the fire we're playing with, consider how content selection algorithms function on social media. They directly influence billions of people. Typically, such algorithms are designed to maximize click-through. That is, the probability that the user clicks on presented item. The solution is simply to present items that the user likes to click on, right? Wrong. The solution is to change the user's preference so that they become more predictable. So why do I tell these 3 stories? I think one thing that I find very interesting is the diversity of the settings and the storytelling and storytellers. So you have Nguyen, a philosopher, sort of working in this tradition of science technology studies, building on the work of anthropologists and sociologists, looking at data collection and sort of bureaucracy in global health. And then you have Cathy O'Neill, a mathematician turned quant turned sort of, I guess, whistleblower on the sort of industry of sort of mathematization in some sense, talking about education in DC in American public schools. And then you have a professor of computer science talking about the trends in AI and these sort of technologies that here in social media start to influence billions of lives and sort of how we communicate in society, and proliferate through all of these other aspects of work and life that we're seeing in this moment right now. And yet, despite that diversity, there are commonalities around basically this attempt to use these sort of what I'm going to term a practice of abstraction for, to answer really important social questions, to get at questions of, what it means, what it means to be healthy, what it means to diet, what it means to be a good teacher, what it means to have a good education, what it means to find work or to be connected with people that you like, that you find meaningful. And yet something has gone wrong in each of these cases with the framing. Through no one's fault, necessarily. There are no sort of obvious bad actors in any of these stories. But something has gone wrong in the framing, and there's an indication that it's a much deeper problem that sort of pervades through society and is going to have wide-reaching impacts. Okay, so to make sense of make sense of these stories a bit from the lens I'm going to present today, I want to say a few words about abstraction and what I mean by abstraction. So a way of describing the world just abstracts another way of describing the world when it treats expressions distinct in that latter way as the same, right? So, for example, there are 5 chairs in this room, or 7 maybe, or let's say 7. And they actually are quite different. As I look at them, I see, sort of black chair and legs. I see this blue thing that doesn't actually have any legs. I see a sofa. These details are all available to me when I use sort of a more detailed frame that takes into account sort of shape and color and so on. But at the level of just a chair, I can sort of abstract this, and these things become interchangeable. These things become places to sit. And if we're only interested in basically how many people can attend a talk in this room, then that's all that matters. So the abstraction becomes useful for focusing attention on and communicating efficiently about, how we can effectively present an appropriate talk or the sorts of talks we can have in this room. But it sort of aligns, for example, are these chairs accessible to someone who is, has mobility issues or something like that, mobility challenges. So again, specifically then the abstraction is used to focus attention on distinctions relevant to a purpose at hand, and make invisible irrelevant distinctions. This is often, abstractions, especially as presented through these sort of technological systems, often presented as some sort of objective thing, like a death classification is like, well, we're just, these are the death statistics. This is an objective way or sort of a rational way of carving things out. But in that, I think it often hides an inherent act of meaning making, an inherent act of talking about, purpose and meaning, and judgments about what is relevant to that purpose. And I think that is where sort of these challenges can sneak in if we don't fully acknowledge and have a practice of abstraction that really grapples with that. So introduce a tiny bit more vocabulary, which will be useful through the talk. I've already said the word frame a couple of times. By frame, I mean a collection of abstractions assembled to provide language for a particular domain or worldview. So, as you sort of get into particular areas, you might say things like domain-specific language, worldview, ontology, schema. As you sort of go, in some sense, into more less formal, first you talk more about worldviews and perspectives. But nonetheless, there is an underlying, well, it's language itself, but there's an underlying sort of vehicle that is present, that is abstract, that people are using to convey their thoughts, that convey, how a system processes information and so on. And then within a frame, I'm going to talk a bit about content from time to time, which is, as content is just, a frame is how you view the world, but a content is assertions of, what the world is specifically like. So a particular, I guess, maybe model, there's a more technical term, model of the world within a frame or within a set of abstractions. So the frames we see in these examples are things like, this classification of deaths, and this sort of divide between this fine-grained classification of sort of deaths from falling from a bed or commode versus these high-level falling from a cliff and other falls. In sort of O'Neill's example, we're trying to frame what it means to be a good teacher. And this frame has notions of things like test scores that are very prominent. And the frame is a good teacher changes and improves test scores, and a bad teacher does not. While I think the frames there are complex and involved, and they can take a while to sort of extract and make explicit and unwind, I don't mean that every frame has to be very complicated, and that's I think an important point. So to give an example of a frame and content, and a piece of content within that frame, I have this box in the bottom right here. Where it's a simple frame for causality, which simply says there are events and there are causal relationships between events where, and it's a cause-effect relationship. There is an event that is the cause, and there's an event that has the effect. And these effects can be both positive and negative. So you can cause, one event can cause more of another event, or it can cause less of another event. So a particular example is that there's the event of rain and the event of observing wet grass, and the event of rain might cause an increase in the event of observing wet grass. Okay, so not only do these authors tell these stories, but they tell them also for a purpose, and this is sort of how they explicate some of the structure or some of the underlying insights in their story, right? So Nguyen says, the problem occurs when users of data forget that categories are social inventions created for a purpose. When these classificatory schemes enter an information infrastructure, they become invisible. They become part of the background operating structure of our world. The power of data is vast scalability. The price is context. O'Neill's rather pithy and sort of precise in her sort of layout of the situation. She simply says there are three elements of a weapon of math destruction: opacity, scale, and damage. And Russell has a long reflection on what's going on. And I've picked apart where he's talking about humility in sort of this practice of developing AI systems. And this quote here is, "Yet uncertainty in the objective of the AI system was simply ignored. In all the work on utility maximization, goal achievement, cost minimization, reward maximization, and loss minimization, it is assumed that the utility function, the goal, the cost function, the reward function, and the loss function are known perfectly. We never really examined this fundamental assumption." So again, the language is different across these three different people, these three different contexts, but I think there are a lot of similarities here. The first is this notion, I'll use O'Neill's word damage, right? That basically the abstraction has failed to capture something actually important to a stakeholder or a person or a community that's impacted by the system. So O'Neill simply says damage. Russell here is talking about basically the uncertainty, the way that the framing the AI system might not actually understand or capture what is really important. And Nguyen talks about this sort of this context as a price, right? It's losing contextuality, it's forgetting things. The next thing they talk about is this notion of opacity, that these systems, just like in the case of Vysotsky, can't really be challenged or something. It takes a while to unpack it. It's a lot of bandwidth, a lot of resources. And then even if you do that, there's no clear channels for saying like this abstraction didn't capture what was really relevant in my situation. So while she talks about opacity, Nguyen talks about sort of the invisibility and sort of them being in the background. And Russell talks about how like these assumptions are unexamined. And then the last element is the scale aspect, right? So we see words like scale, vast scalability, operating structure, infrastructure, and then in the sense of where people are talking about AI, they're talking about this notion of superintelligence or general intelligence, these sort of systems that can operate basically in all contexts, in all environments at scale. So again, despite the differences between these stories, I think there is a really common core. And in my telling, this stems from this initial failure that the underlying frame fails to capture something important to a community impacted by the use of these systems or technologies. And so if this is the way, that to me, this is a problem of the practice of abstraction, and in some sense, one of the features of the way abstraction is practiced today. And my hope in this talk is to invite us to discuss how we might do differently, how we might do better, by naming, an attempt to say, well, why don't we try this path? Right? And so what I'm suggesting here is that we strive for a practice of abstraction in which people can first name the frame. They can articulate when and why the content expressible in a frame cannot or does not represent them, right? Second, from there, it's sort of no use just being able to sort of name what is going on, how you're being limited, what's going on in your experience. We want to give people agency to affect these things. So the second thing I think we need to incorporate into practice is greater affordance to sort of reshape the frame according to the needs driven by some of these individuals being affected. And the third thing that I think comes out in sort of our attempts to work this through is that if everyone is reshaping the frame on sort of an individual, community, or different stakeholder level, then you end up with a lot of different frames. And this, in some sense, is a good thing. But again, if the benefits of abstraction are this sort of vast scalability or this ability to work together across different contexts, then we don't want to lose that. So the third piece that I think is important here is to have a practice of abstraction that allows people to work together across different frames. And so a greater sense of interoperability between sort of abstract frameworks. So the words I've put to this, these three things are the words in the abstract and that you've seen already, which is that I think we should strive for a practice of abstraction that is accessible, responsive, and pluralist. More of the thing, so this sort of practice of abstraction is not a mathematical task, right? I'm not talking about technical work. I'm talking about a social practice, and I'm talking about, a way of orienting all the different participants in these sorts of systems that we've discussed, right? From, again, people doing data collection in global health to people trying to make public policy about education to people building, new media systems or something like that. So I want to be very clear that I'm not saying that mathematics or category theory is the solution, or that this community has some sort of superpower to change everything. It's to enter into a coalition with these sorts of goals. But I think we have something I think we have something unique to contribute. And especially, so mathematicians, I think as a whole, are at the vanguard of abstraction in society. They're in some sense the custodians of the practice of abstraction. And category theorists are this particular group of people within mathematicians that really, look at mathematics itself. And so my hope here is that we can offer category theory as a formal study of the processes of production of abstractions. Where formal, I'll indicate, talks about some notion of accessibility, right? It makes things explicit, much clearer. This sort of the focus on production talks about a responsiveness. If we can talk about how abstractions are produced, we can talk about how they're unproduced or reproduced or modified, reshaped. And this acknowledgement that there's these underlying processes is about, I guess, a way to talk about abstractions in a pluralist way, in a way to work with them in this sort of multifaceted, interoperable way. So the second half of this talk is now to say a bit more, to give you definitions of these words, and then to illustrate, I think, more concretely what I think category theory brings to this sort of practice in our experience. To illustrate what I mean by these words and what category theory brand, I want to first have a brief interlude talking about, and I think I could have picked a bunch of different work at Topos, but I picked CatColab, so a particular software project that is very core to what we're doing right now. So I won't really tell you what CatColab is in detail, but and the examples we go through with this talk will give a greater sense of what it is. But to just set out a vibe, CatColab is a platform for collective sense making via formal interoperable conceptual modeling. And so if you go to catcolab.org, you pull up a system that looks like this. On the left-hand side, we have this is an epidemiological model, the IRV model. On the left, you see the construction of that model as a formal mathematical object. On the right, you see ways to probe what's going on there by sort of visualizing it and exploring what it says about simulations of populations and with certain initial conditions. And so the thing I think we have in mind when we talk about this is these capabilities across like these collaborative spreadsheets like Google Sheets, where initially, especially say in this organization, we whip up spreadsheets very quickly to try and make sense of the complex things that are going on as we carry out our work. There's a form of sort of data management, analogous to SQL. But also data analysis or data science, formal reasoning, version control, and that sort of collaborative tooling. And the aim is to sort of bring all of these affordances into some sort of cohesive package, right? So again, this is a vision, this is a work in progress, but this is the sort of running example I'm going to use. And I think the interesting core of CatColab that is very relevant to this talk today is that it has these layers of framing and then content. And so you have not just sort of a flat sort of universal Turing complete language, and then the expression of content within that language, but we try and structure it very explicitly to have these multiple levels of control over framing content, and then being sort of a categorical approach. At each level of framing, you can talk about things are parameterized in some way. The structure, the framing a level above provides structure. So there's a notion of sort of parameterization and interoperation between frames at the level below. So the way we achieve this mathematically is by producing a declarative language based on double categorical logic. And I think a really important feature of the way we do this is that it's not, this language is not just like double categorical logic is not just used as a design principle. It's built so that every machine readable statement has a formal mathematical semantics. So just to go through some examples for us, I'm throwing out a bunch of category theory words. Those who are in this discussion will have some sense of what's going on, but otherwise I'll move briefly. So we have these 4 layers: doctrine, theory, model, instance. In terms of what these are mathematically, a doctrine is a choice of ambient structured double category. A theory is an actual some double category or presentation of a double category with that sort of structure. A model is a functor from span to set, from this theory to set or span. And so this story is in some sense a categorification, or in a very precise sense is a categorification of the standard categorical logic story. And then one thing to note that though is because we're categorified, we have this level below. So these models themselves are more sort of category theoretic or compositional in nature rather than set theoretic. And then we have sort of a set theoretic structure below, which will turn instance, which comes out of these bimodules. So to think about, so give some examples, your sort of doctrines are things like double categories, if you just want a language or composition, then you can use that. If you want sort of some form of data presentation, you can use double categories or tabulators. You want some sort of logical structure like an and or conjunction, you use Cartesian double categories and so on. At the level below, this permits theories, which are these frames. So like, a causal loop diagram is exactly an implementation of this simple frame for causality that I indicated on the previous slide. But you have, say, the theory of database schemas or the theory of stock and flow models. This is a frame, or the theory of Petri net with links. So these are different frames that, for example, Petri net with links capture as a frame for concurrency or sort of concurrent processes and their interactions. Then at the level below, you have the actual sort of content asserted within these frames. So you might have, for example, a database schema for this international classification of disease, or a stock and flow SEIRV model for some sort of epidemiological situation, or a causal loop diagram of a cap and trade policy. And then for where it's relevant at this level below, this instance level, you then might have, for example, an actual database classified according to the schema above. So that's CatColab. To give one explicit example of just how these frames of content go, this framing and content goes in CatColab. The main, I think, way that we're gonna see this in this talk is at the level of this sort of theory model. So a theory is a frame, a model is content within that frame. And that was exactly what was going on that screenshot of the CatColab I showed. So there is somewhere which was not represented in that screenshot, but I've represented here in this using this technique called sort of an attribute, which builds on database schemas, this sort of stock and flow frame. And it simply says that there are these things called stocks. There are these things for flows that go between stocks. You have, so stocks have a notion of quantity, is implicit here. These quantities can flow between stocks, from an upstream stock to a downstream stock. And sometimes these flows are often influenced by other stocks. So there's these links between stocks and flows, where a link says that this it depends on this stock. The flow of this quantity depends on what is present in the stock. So we see that framing, or this theory declared in the top right-hand part of this model in CatColab, and then we see the construction of the model below it, or the construction of the content within the frame. And then to just have a sense of what this model feels like, there's this visualization. So these arrows here, these double arrows, well, the square blockers are the stocks, the double arrows here are the flows, and there's a link. And so this particular link says that there is a flow from people susceptible to a disease to people exposed to this disease, and that flow depends on, of course, the presence of other infectious people in the environment. Maybe I'll do a quick pause here before I dive into unpacking everything. Does anyone have 30 seconds to breathe, or have any questions? Reading the line. Cool. Okay. So let me tell you about these words I have. So by accessible, and again, these are adjectives applied to this notion of a practice of abstraction. But a practice of abstraction, I say, is accessible to a personal community if it is clear what each frame is capturing and it's clear what is not. Right? So I think this is a really important beginning point, that people may be, as these frames, as these abstractions are used to guide what is happening in people's lives, people have a way of understanding what is being captured. Is capturing my test scores, or the test scores of my students, is not fully capturing, how good my principal thinks my work is. I want to point out that this sort of, sorry, the word transparency, there was one word that I was also thinking about as in this frame of accessibility. But whether called transparency or accessibility, one thing that's very important is relative to a personal community, right? So this is not some sort of, purely technical objective, and this is not something that can be decided sort of once for all. But it's a practice of tracking with respect to all the relevant stakeholders, what is accessible to them. And I think this is something that we can forget a little as category theorists and applied category theorists. So first, I think one thing we do have, a tool we have to contribute significantly to accessibility is formality, is this practice of clear, clearly stated formal definitions which lay out exactly the parameters of these abstractions. But over the next few slides, I'll make a point that it's more complicated than just having better and better and more nuanced, more complicated abstractions that are more fine-grained. So formality is a really important tool for accessibility, especially to mathematicians. And so to give an example, there's this notion of Petri network links we've discussed. And the definition that I'll argue is the clearest, that is the most accessible, is the one on the bottom left, right? It says quite clearly that a Petri net has these things, but reading as a mathematician, I read in this that there are these things for places and transitions, and there's input arcs that run from places to transitions, and output arcs that run from transition to places, and these links that, like the links in the stock and flow diagram, run from sources to from places to transitions, and they have positive and negative influences. Very succinct. It really shows like what is in a single view, what is part of the abstraction, and then also what is not. And so we can compare to, for example, a textual definition from Wikipedia, which I didn't even sort of begin to include these notions of links in. But it is, it's well written, but it is, I think, not as succinct or accessible, in part because it's of a lack of formality. And then another thing I want to point out is that the way that this sort of formality makes abstractions, makes these abstractions accessible, is that given another presentation, so this presentation of Petri nets with links comes from a paper, and in fact written by Evan and a team. And it's easy, I think, as a mathematician to look at these two things and say, these things are both called Petri nets with links, but there is a difference, a clear difference, where we've got an explicit set of polarities here, where a general set of attributes. We have this sort of involution for negativity. And so there's slightly more structures on the right-hand side than on the left. And so while they both purport to capture a notion of Petri net with links, it's really clear, I think, that they have slightly different affordances, and then can probe, what those affordances are and what those what they do and what they do not do. I think this way of making, again, the underlying abstraction really explicit is important. It's not just the title. The title, like Petri net with links, or impact assessment scores or something like that, convey an intent, but in the absence of being able to say like what precisely the abstraction driving this intent or manifesting this intent captures, you lose the ability to interrogate what's going on. So in these teacher assessment tools purport to capture teacher assessment, but if you can make these abstractions explicit and accessible, then you can see, well, they capture a particular notion of what it means to be a good teacher that may not even be desirable. And then you can divorce, what the system or what the abstraction actually does from what it sort of purports to do, and try and reshape it. Okay, so again, my argument here is that this formality is a really important tool for accessibility. But what I want to tell now is a story of how formality is not accessible, right? So there's one story I've really appreciated following over the past 10 to 15 years now, is the story of categorical databases. And a fairly recent paper has a really lovely description of, well, sort of the ways that, in some sense, the sort of themes of this talk, and here things begin to eat their own tail a bit, but like talking about relationships between frames, that is, these OLOGs, or these sort of categorical presentations as presentations frame, and then these notions of interoperability and aggregation and so on in databases. And there's this notion of a duck migration, a disjoint usually conjunctive migrations. it allows this really powerful fine-grained description of relationships between frames that, again, I will say, I think it's really going to be important for many of the themes in the story in terms of interoperability between multiple perspectives and so on. The mathematics itself is written in this paper from the viewpoint of polynomial functors. So it's quite a, it's a 70-page paper or so. It has a lot of detail and sort of a fairly, expert language. To make it somewhat more accessible, we, other people in this room, like in particular Evan and Chris, implemented this in data migrations in a package in this software system we've been writing called Algebraic Julia. Again, from the point of view of category theorists, I think this is very exciting to just give one example. But these duck migrations are required even for some simple examples. So here's basically two different frames on trying to understand enzyme inhibition, one that might be used more by someone in sort of biochemistry interested in sort of the quantitative dynamics of what's going on, and one might be used someone who's looking from sort of a regulatory network perspective or something like that, that is interested in the large sort of the qualitative dynamics of a cell. So this is a simple example, but it's important because it's required even for simple examples. And it's also very highly expressive in general, in some sense, more expressive than sorts of data work you can do in SQL. But as an abstraction, so it's really sort of nailed, I think, a core component of what it means to interrelate sort of content, or interrelate frames and content engineering frames. But as we get into the details, they get detailed. So just to, I couldn't give you a definition all at once or even a sense of what this is all at once. So I'll give it in two stages. First, a conjunctive data migration. And again, I apologize for the jargon. The point, if these symbols make no sense to you, is that this is complicated. So you're probably getting that point either way. So a conjunctive data migration is from, say, a C set to a D set, data in schema C to a data in a schema D is defined by a functor from D to diagrams, the opposite category of diagrams in C. And then just because it's a little satisfying, you can see how this works. Given a C set X, you can basically take this functor, apply X pointwise to C, you get a diagram and set, you take its limit, you get a D set, right? And I think one of the things to note is it's already a bit complicated here because on morphisms, on objects, you can kind of say, you have some intuition quite easily for like what it means to send an object, in D, that is, say, the concept of water to some diagram, some limit sketch or conjunctive query in C. It talks about, water as a hydrologist. What I mean by water as a hydrologist in California is in this climate model, this combination of like the water that is in this geographic region or something like that. That's something you can say in this language. Gets a bit more complicated when you have to talk about like the relationship between things. So say the relationship between water and, I don't know, a plant life or something like that. You have to then, you get these diagrams, you get one limit sketch, which sort of expresses what the concept of water means in this other ontology. You get something at another limit sketch now. Okay, I apologize for the toolbar at the top. And the fourth thing.
Just FYI, it looked all good from our point of view. Brendan, if you're speaking, we're not hearing you. The microphone may have lost battery. Brendan, we are not able to hear you. Can you hear me? Your microphone is not working, at least, or my computer's not working. If someone else.
I cannot hear either, David.
Thank you. Yeah.
It's not working for online.
Okay. I think it's slightly less clear now, but it'll at least be there. Okay, so to speed through this then, the migration, you're already getting a fairly complicated form of natural transformation, talking about conjunctive data migration. A duck migration is another level above this. It's a disjoint union of these migrations. So this category of bundles is a category of discrete diagrams that is basically, collections or sets of diagrams in C. And so then to talk about, what it means to do some sort of migration between these concepts, instead of just sending, an object in D that is some sort of conceptual, some concept to a diagram, you send it to a collection of diagrams indexed by some set I. To talk about a morphism, you have sort of in the covariant direction, you have to map a map between indices, then you get a morphism between diagrams, so you have to track like covariantly. There's a map here, you get a map of diagrams, which looks like this, then you have to do all that sort of tracking. And so at the end of the day, basically what you're doing is you're specifying to every morphism in D, you just have to specify some sort of coherent collection of morphisms in C in some way. But that the bookkeeping, and it's fairly rigid. So once you know what's going on and once you have a clear sense that your definition is sensible, you, as a category theorist, can have a clear sense of the rules and what's going on. But nonetheless, there's just a lot of bookkeeping. And if you're not trained in this practice, or this sort of, you haven't had these years of conceptual, sort of absorption of what's going on, our observation was basically that this sort of software is not really usable, despite deeply capturing, I think, a really important notion of data migration that I think is really important in this, particular example for collaborative science across disciplines. So the point here is that while formality really gave a clear sense to a certain group of people of what is going on, and this is a real promise of, I think, mathematics and of applied category theory, the question is, if this is going to be used by, what I've sort of cheekily termed real people, we need to think about like a bit more subtly about how this formality is used. It's not just a matter of giving people a bunch of category theory textbooks to read, read these 500 pages and then you'll be able to use this excellent software. But it's not, it's not the case then that we should just give up, right? Formality can provide a basis. Formality, I'm saying here, provides a basis for accessibility, not necessarily directly, but by the computational embodiment of the abstraction. And so the ability to give people a guided environment in which they can sort of experience the affordances of these abstractions. So in my example here from CatColab, there are sort of three ways I'm indicating that we're doing this. The first is that because we have a formal mathematical object on the left, we can just visualize what is going on, and that becomes a much more human way to interact with this mathematical object. Second, we can do some automated reasoning over it. Here it's very simple. It's just looking for reinforcing loops. That is things that might go to infinity if you're analyzing this. And third, in this other model, you can start to probe, what are the consequences of these model in particular cases with sort of either real data or sort of fabricated data that makes sense to you, right? So through a sense of being not, you're not reading these on a page and you're not sort of dependent on other people to produce these things for you. It's putting a person, a stakeholder inside the abstraction so they can interact with it and kind of learn its nature and its limits then through experience. Moving on, again, apologies for reasons of time. So I'm going to move forward to this next bit a little quickly. Responsiveness. The second term I have is responsiveness, and I'm saying a practice of abstraction is responsive if a frame can be modified, again, by a relevant person or community without undue cost. And again, so I want to emphasize that this whole idea of viewing sort of, talking about a practice of abstraction rather than properties of abstraction itself is to talk about how it's relative to people, to actors, and in particular, in this case, relative to a level of resources. And so there's this question, what are we doing with category theory? What can category theory contribute? One driver of cost is just the loss of content. As you change frame, you may often have to reconstruct content from scratch. So in a formal way, it's well known that it's just very difficult to port programs between programming languages. They have different frames, the different understandings of what it means to compute. And it's really a long and detailed manual process to often move between those frames. more sort of in a less formal environment, but still in this sort of this experience comes with talking with a collaborator from the field of macroeconomics. There's this DSGE framework, dynamic stochastic general equilibrium sort of models that are key to the practice of macroeconomics today, and everyone sort of has their unhappinesses with these models, right? They don't capture all the things. Macroeconomics is very, very complicated. It's a useful simplifying frame, but everyone's sort of running against the limits. But it's, I think it's the sort of abstract framework they have, and often they have sort of a discrete. These practitioners have a sort of fairly discrete set of abstractions or frames they can use, and they know they don't want game theory or something like that, so they're going to use these ones, this one. And second, if they pioneer something adjacent to it but different, what happens to their ability to partake in this sort of economic conversation, to cite previous work, to build on previous data sets and experiments? Because it's all being reframed, if there's no clear process of translation in frame, it becomes very costly to just build up a whole nother parallel, sort of slightly adjacent discipline. So the example I have here is, again, by sort of having this sort of layers of abstraction, these layers of framing, the frame above sort of parametrizes, or it sort of creates an explicit sense of movement within the layer below. So in this very simple sort of toy example, I'm just noticing that we might be sort of modeling I like strawberries and I'm interested in my supply of strawberries. I might have some sort of causal relationship, but as I try and map this out, I notice that there are these sort of mechanisms between going to the supermarket to buy some strawberries and planting some strawberries in a garden are quite different. They're both causal, but they're actually quite different in nature, and my abstraction is not able to make these distinctions. Nonetheless, what we see here is that these frameworks are hard-coded. I haven't shown you the theory side of what's going on, but I can notice that my ability to express myself with this set of options is not enough. I can migrate the frame to a more expressive frame, and then I can express what I want to express. Right. So this is a way that category theory is helping to inject some responsiveness into the practice of abstraction. And then finally, I want to talk about this notion of pluralism. So our practice of abstraction is pluralist if multiple distinct frames can be used simultaneously in a coherent and productive way. And the reason to do this is to admit that actually, different communities have different interests and different things matter to them. And nonetheless, they want to cooperate and communicate across that difference. So the choice of the frame is one that expresses in some way, what the community has bandwidth and expertise to care about. And the solution is not to construct some sort of, objective, sort of mega, all-inclusive big tent frame, because you lose this ability to direct attention to what matters. So there's this trade-off I write here between expressivity, that is having more potential distinctions, and sort of reasoning or support, and direction of attention, which means that you can make fewer relevant distinctions because you actually just don't want to think about that. And then without this ability to work across frames, then these communities can come into conflict about which frame to use, which makes this project of responsiveness, accessibility and responsiveness, a bit moot. So my argument here is, building on these examples I've shown about these categorical natures and data migration. I've got nothing sort of implemented to show you, but this work, say, on categorical databases and functorial aggregation and doc migrations, leads to an effective way to talk about using multiple frames simultaneously and changing between different viewpoints and seeing how they're in sync and how they're in conflict. And then another thing I think that really helps that category theory contribute to this sort of practice is a greater sense of semantics or meaning in version control, so that we have these tools for managing basically code, these other formal objects, but they manage sort of conflicts in the sense of, well, does one sort of syntactic line differ from another syntactic line? Then that's thrown up to people to manage. But
Brendan,
if,
you're about 5 minutes into your question and
Thank you.
discussion time. Yeah.
If we can direct attention to what meaning, where the meaningful differences are, not just where the syntactic differences are, then we can help navigate this question of pluralism. Okay, so to quickly recap, I'll just skip to this last line here, which is that often applied category theorists, often I have these conversations about providing better abstractions. But I hope we can sort of contextualize this in this sort of wider project of helping with a better practice of abstraction. So that would be a punchline, but I also just want to have a quick thank you to all the people at Topos for the conversations we've been having, and in particular to Tim, Evan, and Sophie, who directly, contributed to this talk. We like to talk about sort of a research neighborhood at Topos, being able to knock on a neighbor's door and ask for some spare milk or something like that. And so I knocked and asked for spare diagrams, spare words, spare titles, spare understanding, and I really appreciate that. And that nature of Topos. So thanks to everyone.
Thanks, Brendan. Okay, we have time for one or two very quick questions. Does anyone, if you have one, just press the react button. Joseph Cornelli, hello.
Hey,
Yeah.
Brendan, it's been a while, but yeah, one of the thoughts that occurred to me listening to this talk, probably because I'm working on a paper about design patterns right now, would be to kind of just have a nice ontology of abstractions, because certainly design patterns are one of them, used by computational folks worldwide, and initially developed, let's say right there in Berkeley, by a bunch of architects. So that's an interesting feature of them as well, is that they're used across disciplines. So that's just an example. But yeah, it might be interesting to look at other forms of abstractions and categorize them briefly.
Yeah, I think that's a great point. We talk a lot about Christopher Alexander here. And I think there's some real insights that we've yet to really internalize.
Great. We probably have quite time for another question, especially a nice quick one.
I have a quick question, Brendan, just of clarification. When we're talking about accessibility, I think it's very clear that we can add the frame and try to be explicit about it. But it seems to me very difficult to try to describe what the frame is not about. And you say you want to have that as well, right? With what that frame is not tracking. Do we have views on how to go about it? I mean, do I make myself clear?
No, yeah, that's at least I think I understand what you're driving at, and I think it's a really excellent question, and it's something that I have thought about, but it's not something I have any real clear thoughts about. I think the angle here, and again, it's within the context. I'm not presenting entire solutions to questions, right? But the thing I'm pointing at here is just that at least if you can try and make really explicit what the frame does capture, you can, by a sense of its boundaries, get a sense of what it omits. I do think it would be nice to have some more explicit way of also saying, rather than an implicit way of specifying what it omits. Maybe there are techniques like things like model cards or something like that, that try and get at this. I don't know to what extent it can really be tackled from a formal perspective, or whether it is actually more sort of some informal process.
Right. Yeah, I'm sorry, I'm not showing myself because my camera is not working. Kind of doesn't like Teams, moving from Teams to Zoom, sorry. But very, very interesting, very kind of very thought-provoking as usual. Thank you.
Thank you.
Valeria. I've heard that there's a question in the room. I think we have time for just that last question from Matt.
Yep.
Yeah, I really like your presentation. The naming the frame reminds me of a Brazilian pedagogist, Paulo Freire.
Sorry. Why don't you come up closer a bit? So people online.
We basically just heard him say that he appreciates the frame, and but I think it was kind of audible.
Maybe the Brazilians in the room, they might know Paulo Freire. The naming of the frame is, I think, like almost one-to-one with that concept. But there's a couple abstractions that bother me, like environments are treated like natural capital and evaluated in terms of their profitability. Cryptocurrency is an abstraction for value is predicated on how long or how quickly can a computer solve a math problem. Enshittification of the internet is where we've reduced websites to whether or not they can gather likes or views or visits, and there's a whole bunch of that. And then the AI is seemingly an abstraction of all knowledge into certain features that we can train machines on. So my question is that the people who are driving this seem to be very much interested in advancing their own tools and have a certain frame of looking at the world, and are seemingly disinterested in the effects that these tools have on what I assume to be real people. So the question is, who is naming the frame for, and how do we achieve working effectively with others who have different frames when some of these perpetrators don't, or actors don't really have much of an interest in changing the way they look at the world?
Yeah, I think that is a great question, tackling basically all the important problems in the world. So I'm not going to have a clean answer to you. I think, I guess I don't mean to enter too much into the discussion of how you change other people, and that this, I think, discussion that I want here is a focus on, what are we doing and what culture can we positively create? And I hope that by creating some sort of parallel culture with, say certain similarities in sort of strength and capability, we can, I guess, build a community that show that give people options for where they want to, the environments in which they want to spend their lives, and devote their efforts. And so I don't know whether that really, sorry, that was a bit garbled.
No, that's fine.
But I also, you picked up on sort of pedagogy of the oppressed, which is something that runs through my mind as I think these sort of topics too. So good spot there.
Well, let's end the official thing now. So let's thank Brendan again. And